Hey guys, just wanted to go over the review with you. We will continue reviewing systems of equations, so let's jump right in. The first one, number one, the events committee buys 100 flowers for a school dance. The flowers are a combination of carnations and roses. Each carnation costs 75 cents and each rose costs $2.75. The committee spends a total of $139, not including tax. The question that we'll be answering today is how many of each type? Well, in class, we talked about this whole idea of quantity versus value. So my quantity will be, in this case, the actual types of flowers, which is the question itself. Most of the time, the quantity comes from the question, or the value is also from the question as well. And you'll see here later. So let's worry about our quantity equation. Our quantity equation is going to be the actual items. So I'm going to go ahead and define my variable. I'm going to say let C equals carnations. Let R equals rose. So every time we see an R, it means rose. Every time we see a C, it means carnations. So my quantity equation is going to be the total number of flowers the school dance bought. Well, they bought a total of 100 flowers. The quantity will be what is the combination of flowers that makes up that 100. In this case, it would just be carnation plus rose. Let's talk about my value. Now we actually go in and assign a value of the cost of each of the quantities. So each carnation is 75 cents. 75 cents C, or 7,500 C, plus $2.75 R is equal to, instead of writing 100, because that 100 is actually what makes up the total amount of flowers bought, it's going to be the $139. And there's my system right there. My system is made up of C plus R is equal to 100.75 C plus 2.75 R is equal to 139. And there's my quantity and value. Let me line it up a little bit better here so we can. I got my restrictions, I got my constraints. 100 total flowers, they spent a total of $139. And from here you guys can solve it however you want. I'm going to go ahead and walk you guys through on how to use the elimination method, just because I noticed that C and R are on the same side of both equations. If you want to do substitution, you can, but I'm just going to eliminate. And since R is C and R in the first equation, so let's say this is equation A and this is equation B. Equation A, both of these are coefficient of 1. I'm just going to eliminate R. That's my goal. So I'm going to look at the second equation. 0.75C plus 2.75R is equal to $139. Right now, if I do something called systems of elimination through addition, nothing eliminates because I don't have any zero pairs. So I'm going to choose to eliminate R. And the equation B, 2.75R, that's a positive. So I'm going to choose to multiply equation A by negative 2.75. I'm going to multiply the entire equation by negative 2.75. Oops. And that's possible because I'm just creating an equivalent equation. It's just like the same thing as in class when I say 1/2 is the same as 2/4. We can multiply our entire equations to create multiples of each other. And then I'm going to rewrite equation B right underneath of it. So after I multiply, let's do the distributive property. I'm going to distribute negative 2.75 everything on the inside of the parentheses. Everything in the entire equation gets multiplied by negative 2.75. So my new equation A is going to be negative 2.75 C plus negative 2.75. Don't want to write the 7 today. 75 R is equal to negative 275. Okay. Again, I'm just multiplying by 100. You move the decimal twice to the right. So if I, right now, in my new equation A, here's in red, if I divide everything by negative 2.75, I get the original equation A. These two are still equivalent. Now let's write equation B right underneath of it. The original equation B. 0.75C plus positive 2.75R is equal to 139. And there's my zero pair that I wanted. I wanted to zero those out because I'm going to do something called system of elimination through addition. I'm going to add those two equations together. And negative 2.75C plus positive 2.75C, think in terms of money. It is actually money. If I have a negative $2.75 and I add 75 cents, that's a positive, all I have left is negative $2C. Or, in this case, we can just simply write negative 2C. And that zeroes out is equal to negative 275 plus positive 139 is equal to negative 136. So I'm going to go over here now. So right now I have negative 2C is equal to negative 136. In the solve for C, I divide both sides by negative 2. In this case, I do have a positive answer. So I have a total of 68 carnations. And once we have 68 carnations, we take this in and I'm going to substitute it back into equation A. I'm going to go 68 plus R is equal to 100. Subtract 68 from both sides. R is equal to 32 roses. So there is my answer. So I have 68 carnations and 32 roses. And we better check our work. It's got to work for both equations. It's got to work for both equations. So if we, so I'm going to zoom in a little bit here. I'm just going to go up to the right here. If I did 68 carnation times 75 cents plus 32 roses times 275 apiece, does it equal $139? Okay, and $68 times 75 cents is going to be $51, and 32 roses times 275 apiece is going to be $88. And when I add those two together, it does equal $139. So my answer is correct. I do have the right combination. 68 carnations and 32 roses. And that's how you do systems of equation through elimination. Okay, now if you did the substitution, I hope you got the same answer. Speaking of substitution, let's just jump right in. Let's do this first one. I have y is equal to 3x minus 2. Y is equal to negative x minus 6. Now in class, we worked on solving systems through graphing. You can definitely graph this if you want to see where they cross. Right now I know this have one solution point because my slopes are different. And since my slope is different, they cross at one point. But see how these two y's are equal? That both of these equation A, equation B. So here's equation A, here's equation B. Both of those are y is equal to. So in other words, we can think of it as since both is set to y is equal to y. So I just write my equation A, my expression, which is 3x minus 2, is equal to negative x minus 6. And from here, I solve for x. I'm going to go ahead and add x to both sides. I get 4x minus 2 is equal to negative 6. Add 2. I get 4x is equal to negative 4. Divide both sides by 4, x is negative 1. And now that I have x is equal to negative 1, I'm going to go back up to the top here, and I'm just going to write y is equal to 3x minus 2, and then now substitute that negative 1 back in to find y. 3 times negative 1 is negative 3, minus 2, y is negative 5. And again, before I move on, I want to double check to make sure it works for the second equation, my equation B in this case. So does negative 5, because that's y, equal to negative x. So I just write negative and then substitute in x, which is negative 1 minus 6. Well, negative 1, the opposite of negative 1, that's positive 1 minus 6. Yep, I get negative 5 is equal to negative 5. So my answer does check out. So my solution point is negative 1, negative 5. Okay. Let's go to the second equation B. Now if I'm going too fast, which I know I am, don't worry about it. Just pause, rewind, and then feel free to email me questions, and I can walk you through a couple different, show you some different situations. Here I have y for equation for B. Y is equal to 6x minus 11. That's equation A. Equation B is equal to, equation B is negative 2x minus 3y is equal to negative 7. Well, I have one of these equations that is already set to y is equal to. In class we talked about this is my star, or the same like this is my dollar bill, the y is the dollar bill, on the other side is 100 pennies. It's the same idea. So what I'm going to do is I'm going to substitute equation A into equation B wherever I see a y. So this two y's are equivalent. They're the same. So I'm going to substitute equation B looks something like this. Negative 2x minus 3, but instead of y, because there's y, equals negative 7, I'm going to drop, or I'm going to substitute in the quantity of 6x minus 11. Because those two are the same. Y is equal to, it's like when I say y is equal to 5, most of you would just, wherever there's a y in the second equation, you would just substitute in 5. The same idea. And from here we follow our protocol. First thing we need to do is we see parentheses, so we need to clean that up. So we need to distribute. Now that's a negative 3, so I get negative 2x with negative 18x with positive 33 is equal to negative 7. Next step, let's clean up one side before we start maneuvering things around. I notice that those two are the same, so I get negative 2x combined with negative 18x is negative 20x plus 33 is equal to negative 7. I need to move that positive 33 over to the other side, do the additive inverse, which is the opposite of positive 33 is negative 33. This zeroes out. I get negative 20x is equal to negative 40. Divide both sides by negative 20, and x is negative divided by negative is positive, so x is equal to 2. We're not done though. We're not finished, because now we need to find y. We have x, so now we need to find y. If we go back to our original equation, one of them, equation A, is already set to y. So y is equal to 6x minus 11. I take this, now we substitute it in right there. So I get y is equal to 6. Instead of x, I write times 2 minus 11. 6 times 2 is 12 minus 11. Y is 1. And there's my answer. I get 2, 1. Okay, and that's going to be part 1. I will do the last 2 questions in a different video. Okay.